Okay. It's good. Wrong camera. Sorry. Give me 1 second.
All right.
Okay.
There
That's
we go.
that's better. Yeah. It was just wonderful. So this was the global NeuroHack. It was 3 days, Friday through Sunday, and 16 universities, but maybe 14 teams. Like a few people grouped up. Well, actually, maybe 16 teams. There were people showed up that we didn't know. Like one guy was working on, I think, like speech decoding, and the students had a Discord, no, like a Slack for the organizers, and they're like, there's one guy working on he says he's Georgia Tech, but he's working alone.
Yeah.
like we're not sure how he even heard about this, because it was a little strange in the sense that, I mean, I did have people showing up being like, hey, there's a hackathon, and it's like, yeah, but like universities are sending teams of 5, like it's you kind of need to be with a team, and but it was great, and I think Georgia Tech guy came second.
Oh, wow.
I mean, I think he's a bit of a ringer. Um, uh, there was also a mix of grad students and undergrads, and um, and historically we've been just undergrads, so that students competed in 3 tracks: blue sky, speech decoding, and Science Corp did a track, which was just awesome. So this is one of the co-founders of Neuralink who left, Max Hodak, has a company called Science. Worst name ever.
Yeah.
And it like came up multiple times in the weekend. People like, "Are you with Science?" And then somebody's like, what do you like? Aren't we all? um, but they were so great. They sent a whole team. Like they sent like 3 engineers, 4 engineers, and a media guy.
Okay.
And what was also very cool was like how many freshmen actually came.
Okay.
And to that point, so the blue sky track winner was 5 freshmen from UC Santa Cruz. So that just goes to show, I mean, blue sky was like particularly suited for that in that you didn't have to build something.
Oh, okay. Yeah.
Right. So it was kind of a proposal, but like at the same time, I think they won the judges over with both the kind of like practicality of it and the presentation. I mean, I would say something. I would say like, for good or for bad, your blue sky presentation was very key.
Yeah.
Yeah, but the main thing being that the students left like super energized. The fact that they all took this huge risk of flying to San Francisco, for this in-person event, which had never been held before, right? Was big, and but yeah, it was great to have so many people came out to meet with the students and help and mentor them, or serve as judges. We had the head of neurosurgery at Neuralink came to speak about the kind of work that they do. Um, Precision was there, which is another one of the companies that started from people, co-founders leaving Neuralink and starting a new company. And I think that was also really great for that was exactly what the students had asked for, was like, hey, it's not so much the financial prizes, but if we're doing this in real life, can we meet people and get to talk to people we wouldn't normally have a chance? And so I just, like so many people came through on that. And uh and they had we did have, I'm biased of course, but we had a great venue for them. Not just the event space, but like I could spread them out across this huge building. They could have their own conference rooms and things like that to work in. So um, what I'm excited about is to see, in maybe a month or two, um, how many of those groups that I'm still talking to, how many of those groups are, um, I mean, they went back energized. That was the good thing. And um, like it was funny too, where I had organizers being like, I'd say like, oh, so how's it going? What are you working on? And then somebody's like, uh, actually, I was wondering, could I get a room so that I can go work on my homework? you know, um, like these are all students in the midst of their academic semester. You know, I yeah. So it was really great to have one, to meet all these students that I'd been talking with for like 4 months, and um, and seeing all their work come together, and seeing like all these students show up who'd never been, because there's so many freshmen. um I'm hoping big things from this particular group in Santa Cruz. If they're just freshmen, like what are they going to do as sophomores or juniors? um so it was great weekend. And then the so some of this week has been just wrapping that up, as well as kind of catching up on things that I hadn't had time for um, the week before, as it kind of got crunch time. But I met with the head of the connection program. So this is the group that that I worked with last year, teaching neuroimaging analysis to mostly biomedical engineering students, and radiology adjacent people in Africa. Um, so this is a program run from McGill, professor who's at McGill, but has an AI and medical imaging lab in Lagos. And so really cool um, meeting, in terms of just how how the program is progressing. um, she has historically had two initiatives. One is Spark, which is more of the AI related, work in medical imaging, and then one's the Connection, which is a bit more of the kind of uh, particular neuroimaging analysis of MRI data. It's also part of CAMERA, which is the democratization of MRI in Africa. So just really cool. So I'm joining the chair committee, or the kind of organizing committee for the group, and there's really interesting projects in terms of collecting normative data sets in Africa. So that's really exciting in terms of representing something equivalent to Enigma in Africa in terms of collecting a normative sample, as well as beginning a program of imaging genomics. And as we know from large scale medical kind of global health initiatives, that it's super important to have that global coverage. Excuse me. So there's some work I can show real quick. Excuse me. Some of the I'm not going to spell this guy's name right, but hopefully I can find. So there's a group at UCSF. Yeah, this is the funny thing being that this is based here in San Francisco, and let me. Oh. I am just putting in Augustine here, but his let me just get his scholar. Because it he captures this kind of global health really well, I think. Or like what's possible with this global health. And one second. That's so important. Okay. So he's mostly been doing this in well, I shouldn't say only, but like he has his big focus as a Argentinian researcher. He has his big focus Latin and South America. And is really valuable in terms of not only capturing the kind of like genetic profile that is regionally distributed, but and this is the exposome across multiple regions. So I'll just put in one paper here, really indicative of his work. So it's exciting. We'll be teaching, so we've got a new cohort of uh, analysis students, kind of like learning different neuroimaging, as well as a much larger group that's learning AI in medical imaging, specifically, working on those kinds of projects. and then there's this data collection piece to it in terms of actually seeing, collecting an African cohort of data, and things that you can specifically do with that is also really important. But Adana has had I think it's one of her interests is to have that for the students to work with too. That, like, these are African students working on a really African neuroimaging initiative that's actually making a contribution to global health understanding. And yeah, so that's also really exciting. A lot of so there's some grants that are focused on kind of some of the issues that I'd really seen with the students in terms of our compute resources and things like that. That's exciting to see the progress on that. Still remarkable progress, although some I think I'm perhaps interestingly getting to the point where now, Claude can't save me when the physics becomes the problem. So, it's I think a lot of my early successes have been, somewhat, not somewhat, mostly aided by the fact that in a lot of analysis pipelines, I had lots of clear examples to work with. So I was mainly, to some extent, I was really just re-implementing certain things but in JAX, so that it gives me this computational benefit, right? And then that computational benefit can be leveraged to provide a new kind of simulation-based inference that allows for somewhat of a different way of working on problems, and something that's very amenable to some novel approaches that are computationally efficient, as well as providing great kind of Bayesian analysis with uncertainty. Some of the work that I've started doing now is actually hitting some really open problems in computational physics. and and I'm seeing now where it's just like, now Claude is making normal mistakes. Or like now, we don't have any right answers to draw on. So it's like kind of like the last papers on some of this. So the project to check out is actually called so sorry, it's just brain FWI. So for full waveform inversion, I'll just drop this in if anybody wants to see it. But this is a technique that was started in the 80s for geophysics, it's incredibly computationally expensive, and so to get preliminary results has been a really interesting. Now this is something where Claude has to run experiments in the sense of Claude is trying things and they're potentially not working, um, or they're potentially making things worse, or they're good approaches, but they blow up computationally. And I'm on this DGX Spark, which is it's a nice 128 gig unified memory device, but uh, but at even like medium resolution, this is the I'm getting out of memory uh, errors, and so this is really interesting. It's a great place to be finally, where I can also try and run some of this work that um, that I started from. I mean, I've been running, especially in my quantum simulations, the kind of minority game, um, computational social science slash computational chemistry. Um, uh, but this agentic SciML for like multi-agent systems to solve um, these particular kinds of problems where can it's a little, I mean, it is a little like like an AI scientist. um uh yeah so I gotta say that, interestingly, um the approach that I've found to be the most successful is actually using an LLM to do evolutionary um, search algorithms, um, which I think is funny, because that is not agentic. That's not the AI scientist approach. It's very much a kind of gecko approach. Um, um, but I found that has helped with a couple problems where there wasn't any clear answers from the literature or anything like that. and a grid search was especially with neuronal, so like large scale neuronal cultures, where you really needed to find kind of like where particular um, nonlinearities existed in this kind of like lost landscape. Anyway, um, that's it's reached a really interesting spot. It's like, I think for data analysis, I'm more convinced than ever that like you should be using Claude. um, when it's just putting together scripts, and uh, of kind of like known pipelines and things like that.
Hmm.
Been doing some really I've been doing some hardware development now. So you can see this in the free EG 128. So I've got this. This is a particular. This is a super low cost amplifier system that I can, basically almost approach, $1 per channel for a high density EEG system. And yeah, this is doing firmware development now. um, uh, I've got Claude writing some well, I should say rewriting some experiments that come from an old task that I would like to get going for next week is the GTech Spring School for Neurotechnology and Brain-Computer Interface. And so I've got a couple things that I'm working on that I don't know whether I'll necessarily compete in the hackathon, but I would just like to do something for the for this event. And there I can't say enough about how useful this is to have. I feel like it's not only that it is a useful coder, but it gets me it's it gets me past humps where I think I would have maybe given up um, uh, in ways like they weren't so challenging, but to get to like stay that focused on something for the amount of time that it would need to be, whereas like Claude can be just doing this in the background is uh, yeah, good for us multitaskers anyway. But
Yes.
I think it's interesting to have it hit a problem where um, where I'm really up on the edge of something and seeing how um, seeing how it both approaches things, as well as like this is one of those times where I think AI scientists is not something that that these models are doing well.